Well, welcome back, class. It's time for chemistry again. Today we're going to dive into limiting reactants. So, here's our problem. 5 grams of aqueous lead nitrate is added to 4.0 grams of potassium iodide. What precipitate forms and how many grams are produced? Get the cobwebs out. Let's go. It looks like first there's less grams of potassium iodide, but we do need to work through the problem. Okay, so first thing, balance the correct equation. All right, so we know, looking at a periodic table, we know lead is Pb with a 2+ charge. We know nitrate, or we can look it up, it's a polyatomic ion with a, we're going to do that, 1- charge. We know that potassium is alkali metal, let's say 1+ or plus charge, and iodine is a halogen, it's a 1- charge. So that way you can write the correct formulas. So lead nitrate will be Pb, 2+ with a 1-, so it's going to be PbNO3 2 plus potassium iodide, that's simple, Ki, and it will produce the double replace reaction, lead iodide, PbI2, and potassium nitrate. Okay, 1+, 1-, that's good. All right. Now, those are the correct equations. Now we need to balance it. All right, 1 lead on this side, 1 lead on this side. That's good. 2 nitrate groups. Only 1 nitrate group over there, so we need to put a 2 in there. Okay, now that gives us 2 Ks over here, so we need to put a 2 here, and then 2 iodines and 2 iodines, so that's good. All right, so there's your balanced correct equation. Okay, what precipitate forms? Now you have to go back and maybe have to look at your solubility charts. But let's put this in. This is aqueous, they tell us that. So AQ there. This is aqueous, AQ there. And then over here, this is an iodine, okay, with lead though, we know that is a precipitate. So we're going to put a solid there, so that's our precipitate. We also should know that nitrates are always soluble. You can look it up in your chart, so it's aqueous. So we want to know how many grams of the lead iodide are going to form, okay, so that's what we're going to look at. That's the product, we want to know how much there is produced. All right, so we got this done, balanced correct equation. Mass to mole. All right, so what you got to do is you have to figure out how many moles you have of the lead nitrate, and how many moles of the potassium iodide you have, and then you're going to see how much of the lead iodide will be produced from each of those. All right, so let's go. Mass to mole first. All right, we have 5 grams. You guys recall, moles is mass over the molar mass. You can't forget that even after a month. All right, so you got 5.0 grams. You figure out the molar mass of lead nitrate. It's going to be quite large. When you work it out, it comes out to be 331.10, excuse me, 0.20 grams per mole. Okay, so if you do the math on that, 5 divided by 331.2, it comes out to be 0.015 moles of PbNO3. I'll make that kind of small so I'm going to leave room. Okay, for the potassium iodide, figure out how many moles we have there. Moles of the Ki. We only have 4 grams, so 4.0 grams. Divide that by the molar mass of Ki, which is 166.00. 0.0 grams per mole. Okay, so that comes out to be 0.024 moles of potassium iodide. All right, you with me so far? Okay, so looking at it now, looks like, okay, well maybe this would be the limiting reactant because you have less moles of this than this. Okay, but you're not done yet. Okay, we've got to go to the mole ratios. Okay, you got to compare, and the least one wins. Okay, the one that produces the least amount of lead iodide. We're interested in how much the lead iodide is produced, so just set up a ratio. Pb NO3, okay, over PbI2 equals PbNO3. Looks like a lot of work, but you stay organized. You know there's a law of least effort. You want to do the least amount as you can, but that's not good here. So let's see what happens here. What's the mole ratio here between the lead nitrate and the lead iodide? Well, look up here. It's a 1-to-1 ratio. So that's simple. 1 is to 1, like 0.015 is to X. So X is going to be 0.015 moles of lead iodide. Okay, so if lead nitrate is your limiting factor, you're going to produce this much lead iodide. Okay, now we have to compare that over here though. Put a little squiggly line there to divide it. All right, but here we have Ki over PbI2 equals Ki over PbI2. All right, but here now the mole ratio is a little different. We got a 2-to-1 ratio, so it takes 2 to make 1. But here I have 0.024, so 2 is to 1, like 0.024 is to X. You solve for X, and it's going to come out to be 0.012 moles of lead iodide. Okay. Remember, we want to choose the one that produces the least, so 0.015 is bigger than 0.012 moles. So there is your least product. So that means that the Ki would be your limiting reactant. All right. Now, the question asks how many grams are produced. Okay, so last thing, mass. Okay, remember is moles times the molar mass of that particular item. So we got 0.012 moles of the PbI2 times its molar mass, which is big, times 461.0 grams per mole. And if you do the math there, it comes out to be 5.5 grams of PbI2. Now, you can stop this. I know I went pretty quick, but I wanted to do that in the time limit. I do have the demo right here. Okay, real quick. You notice lead nitrate is a white crystal. Potassium iodide is a white crystal. You put them together and mix them up. Nothing happens. Oh, it's turning a little bit yellow. Okay. Why do you think that is? Well, it's because there's a little bit of humidity in the air. Okay, but when you dissolve them, much more dramatic. Doesn't matter which one you pour into which, but let's do it. Let's see if we get a good result. Turn it around so you can see well. Here we go. There we go. Miss you guys, and okay, do the worksheets, study your chemistry. Good night.